First part of the question, we're asked to list the conditions under which we can use a normal distribution to approximate a binomial. Well, there are two conditions: if the number of trials is large, or if the probability of success is close to 0.5. In the second part of the question, we've got a random sample of 20 orchids and we're asked to find the probability of x equaling 10. Well, if there are 20 orchids, then it's going to be 20 choose 10, 0.45 to the 10, and then 1 minus 0.45 to 20 minus 10. Lots of calculations to do there, but our final answer is 0.1593 to 4 significant figures. Okay, part C, use a suitable approximation to find the probability that fewer than 110 orchids produce pink flowers. This is from a sample of 240. So x is distributed binomially. We've got a sample of 240 and our chance of success is still 0.45. Let's find out the mean. Mean NP, 240 times 0.45, so gives us a mean of 108. Our variance then is NP 1 minus P, which gives us 59.4. Remember, that's the variance. So we have a normal distribution, mean 108, variance 59.4. Let's map out our normal distribution as per normal and label our mean there. Right, we're interested in 110 or fewer. So 110 or fewer is there, and we're interested in this section here. Now, because it's 110 or fewer on the discrete distribution, that's the same as less than 109.5 in our normal distribution. We have everything we need for the normal distribution, so that's very easy to calculate as per normal when we get 0.5772 on our calculator. Final part, part D, is a little bit harder. We find the probability that Q orchids produce pink flowers is 0.2. So in our discrete, we've got x greater than or equal to q is 0.2. Well, okay, there's q there, and we're interested in the section above it. Now, of course, q goes from minus 0.5 to plus 0.5 when it's a normal distribution. That whole section there has got to be 0.2. So when we mapped to a normal distribution, it's probability of y greater than or equal to q minus 0.5 equals 0.2. Obviously, if we could turn that around, then it's y less than or equal to q minus 0.5 is 0.8. Inverse normal on both sides, and we get q minus 0.5 is 114.486. Adding the 0.5 to both sides and rounding to 3 significant figures, we get 115.